Prabir,
Roy Chaudhary,
Prabir, yeah.
uh, and he will be talking on yes, we can cure kidney disease. And thank you, Dr. Roy Chaudhary, for doing it today, the CME webinar. And I want to welcome Dr. Amit Govil, the CME chair, to introduce the speaker and moderate this session. Thank you, Dr. Goel.
Okay. Thank you, Satish. And it gives me immense pleasure to introduce the speaker for today, Dr. Prabir Roy Chaudhary, who happens to be my mentor as well. He is currently the doctors Ronald and Catherine Falk, eminent professor of nephrology and co-director of University of North Carolina Kidney Center, with research emphasis on vascular biology and translational research. He has been over the years very well funded by NIH and other clinical trial agencies, and actively involved in public policy and administrative aspects of kidney disease, and pretty much was a co-founding member of Kidney Health Initiative, which is a public partnership between the American Society of Nephrology and the FDA. It's and multiple other societies. So if I start listing all that, I think I'll probably be spending most of the time talking about him. So, and he's also currently the president of American Society of Nephrology. So, without any further delay, I'll let Dr. Prabir Chaudhary talk about the most important thing for us in the world of nephrology, but in general for cardiokidney metabolic disease. Whether we have anything that we can do to slow down the kidney disease or maybe even cure it. Welcome, Prabir. Thank you.
Great. So I just want to start off by thanking you, Dr. Kathula, for this opportunity. Amit said that he was my mentee, that I was his mentor. What I do want to say is that I think, Amit, you've created your own career, and if you are my mentee, you're clearly by far the most successful of my mentees. So again, very grateful for this invitation. Let me share my screen and okay, sorry, what might I have? Okay, so there, got to do that. And let me put up my talk and go full screen. Okay, so I just, and let me minimize the things over here. Okay, so I just want to be sure that all of you can hear me well and that you can see my screen. Amit, if you give me a thumbs up. All right. So what I'm going to talk about today is really about kidney disease. And I'm going to challenge you a little bit in this presentation. But first, these are my disclosures. And to summarize what I'm going to say in this presentation, I'm just going to open it a little bit so I can see myself also. So what I'm going to sort of go through in this presentation is that I am initially going to describe to all of you the innovation, the change, the excitement, and I think very importantly, the hope, because hope is a very, very important word that is currently transforming, I would say, the traditional fabric of kidney care. But then through this fabric of innovation and change, and once again, I'm going to mention hope, I am going to weave a very strong thread of other things, things like education and awareness and equity and access to care and policy, which in many ways are the true engines of change. Now, in this presentation, I'm going to talk a little bit about chronic kidney disease. I'm going to talk a little bit about hemodialysis, and I'm going to talk a little bit about transplantation. Most importantly, though, what I'm going to talk to you about is going to be ambitious. It's going to be audacious, but I believe that it is also going to be something that is eminently possible to do. So with that, let's talk a little bit more about chronic kidney diseases in general. And the first thing I want to say is that chronic kidney disease is common. 850 million people worldwide, including 37 million in this country. It is the 8th leading cause of death in the United States at the present time. But despite its magnitude, 9 out of 10 US adults who have chronic kidney disease don't actually know that they have it. And it is extremely expensive. $50 billion for end-stage kidney disease, $130 billion for all chronic kidney diseases. Now, if you think about the causes of chronic kidney disease, there are 3 main causes: diabetes, hypertension, and glomerulonephritis. And 2 additional points that are very important is that regardless of the sort of initial disease, there is a final common pathway of fibrosis, which means that this is something that we can target across all forms of kidney disease. And the second important point is that chronic kidney diseases are a global problem that is growing. Now, I want to focus a little bit on the global issues and the growing issues. So if you look at the left panel, you see that in 1990, chronic kidney diseases were the 18th most important cause of death. It has now grown up to the 9th most important cause of death in 2021 when you think about it globally. So it's increasing. The second important point about chronic kidney disease comes from the picture in the top left, and this is critically important. And what the picture of the panel on the top on the top right, I beg your pardon, from Alan Go's work shows is that as your kidney function decreases, so too does your risk of cardiovascular disease increase. And there's actually data which demonstrates that if you are a young 18-year-old man with end-stage kidney disease due to, let's say, IgA nephropathy, your mortality risk, particularly from cardiovascular disease, is 100-fold greater than an 18-year-old without kidney disease. In fact, it's very similar to that of an 80-year-old without kidney disease. So then finally, if you look at the right lower panel, the burden of kidney disease comes from premature mortality, often due to cardiovascular disease. It comes about as a result of a huge decrease in the quality of life, and it causes a huge economic cost to healthcare systems across the globe. Now, I want to emphasize the bit about 30 years ago, right? We said that over the last 20 to 30 years, the impact and the magnitude of chronic kidney disease has increased. Well, that period of time, and I'm smiling here because it makes me old, is where my story actually overlaps with the kidney disease story. Because I started my career also as a nephrologist in the early 1990s when CKD was the 18th most important cause of death. And I remember very clearly as a fellow that the captopril study had just come out. I was a fellow at the Beth Israel Hospital. And I was excited that within the kidney community, or as a nephrologist, we now had a drug that was ours that could prevent the progression of kidney disease. And I absolutely expected that there would be a succession of new therapies that would keep coming out. But the reality for most of my career, in fact, was a 25-year drought where we had no new interventions, no new therapies, other than perhaps the introduction of angiotensin receptor blockers, which are basically a cousin of ACE inhibitors. But then in 2019, at the World Congress of Nephrology in Melbourne, everything changed, because that was the year that the Credence study came out, which showed that SGLT2 inhibitors actually have a very marked and beneficial effect on both chronic kidney disease and on the cardiovascular disease that occurs in patients with chronic kidney disease. And since then, there has been a flood of new therapies that have come into the chronic kidney disease space that also have cardiovascular benefits, in addition to innovative therapies for different forms of glomerulonephritis. And so the message that I want to give to all of you, whether you're nephrologists or not, is that in the kidney disease world, we are actually at an inflection point. And as nephrologists and as practitioners of medicine as a whole, we have to grasp this moment in time. Because if we don't, then nephrologists like me may have another 25 years of stagnation. And most importantly, our patients cannot go through another 25 years of therapeutic stagnation. So let's talk a little bit before we go into the actual therapies, into the mechanisms of progressive diabetic kidney disease and chronic kidney disease. And you can't talk about diabetic kidney disease without recognizing Dr. Bakris, who was both a friend and a colleague, and who unfortunately died at a relatively young age last year. George was a master of being able to take complex paradigms and simplify them. And this is a picture or a cartoon that he came up with, which emphasizes that there are three important mechanisms really for both progressive diabetic kidney disease and chronic kidney disease: metabolic dysregulation, inflammation, and hemodynamic perturbations. Now, the reason that this sort of a construct is so important is that once you have the different mechanisms, you can target the different mechanisms. And the exciting thing about chronic kidney diseases at the present time is that we actually have drugs that can target the metabolic dysregulation, the inflammation, and the hemodynamic perturbations. And I'll speak about all of these different drugs in a moment of time. But the real world is actually a little bit different from the world that is beautifully projected here. So you would think that the way that we got these new therapies that I'm going to speak about was that we identified the mechanisms and we targeted the mechanisms. Partly true, but not completely. Here's the rest of the story. If you're as old as I am, or maybe even as old as Amit, because I think you've used this drug, in the mid-2000s, there was this drug called rosiglitazone, and I used a lot of it. It was called Avandia. But then after we had used it in millions of patients, the Cleveland Clinic group, Dr. Nissen came out and showed that these agents had significant cardiovascular risk. So Avandia was actually taken off the market. But what this also resulted in is that it resulted in the FDA asking for cardiovascular outcome studies for all new anti-diabetic drugs. So the next new set of anti-diabetic drugs that came into being were the SGLT2 inhibitors. And when the cardiovascular outcome studies were done for these sodium glucose cotransporter 2 inhibitors, instead of bad things happening, good things actually happened, in that there was a huge reduction in the number of cardiovascular events. Now, this was in a general population, but very soon a large number of studies were done in which SGLT2 inhibitors were demonstrated to be effective in improving a composite kidney or a composite cardiokidney primary outcome, regardless of the presence of diabetes mellitus, so both diabetic kidney disease and chronic kidney disease. And this occurred across a range of eGFRs and UACRs. And you can see the relative risk reductions in these composite kidney or cardiokidney endpoints of between 28 and 39%. So a huge, huge impact on cardiokidney disease. Now, this was not the only set of new therapies that have come into being rather in the last 5 years. Finerenone is a non-steroidal mineralocorticoid receptor antagonist. And again, there have been two large studies, the Fidelio study, which had a composite kidney endpoint, and the Figaro study, which had a composite cardiovascular endpoint as the primary endpoint and a kidney endpoint as the secondary endpoint. And both these studies have unequivocally shown that you get relative risk reductions in diabetic kidney disease in the composite kidney outcome of about 27%, and in the composite cardiovascular outcome of around 14%. So again, a second group of drugs or a third group of drugs, ACE-ARB, SGLT2 inhibitors, non-steroidal mineralocorticoid receptor antagonists that can be used in chronic kidney disease. And then finally, in June of last year, a huge study called the FLOW study, where Ozempic was actually demonstrated to reduce, again, both a kidney endpoint and a cardiovascular endpoint in patients with chronic kidney disease and type 2 diabetes mellitus. And just about 2 weeks ago, the FDA actually approved Ozempic for the treatment of chronic kidney disease in patients with diabetes. Now, this is really exciting stuff, obviously, but it also brings up a lot of other questions. So, for example, how should we use these drugs in diabetic kidney disease and chronic kidney disease? Should we have a tiered approach, as is described in the KDIGO guidelines, where initially these guidelines say you should use ACE-ARB, followed by an SGLT2 inhibitor, and then a non-steroidal MRA, and of course, the GLP-1 agonists had not come out when this set of guidelines came out. Or should we use it like the cardiologists use it, and as Dr. Bakris wanted us to use it, which is to have the pillars of therapy approach in which you use all 4 drugs because they target different mechanistic pathways. So ACE and ARBs would target mainly the hemodynamic perturbations. The SGLT2 inhibitors would target both hemodynamics and inflammation. And of course, Findranone, which is a non-steroidal mineralocorticoid receptor antagonist, so another version of spironolactone, but with marked differences, would target primarily inflammation. And then the GLP-1 receptor agonist obviously would target metabolic dysregulation. And I actually tend towards this, and perhaps I've been influenced by my son, who's a second-year cardiology fellow. And what Akshay tells me is when somebody comes in with heart failure, with new onset heart failure, the cardiologists, and I'm sure there are cardiologists in the audience, so I'd love your thoughts as well, but these patients don't go out unless they're on 7 different drugs. And it's only if they're falling over as a result of these drugs that the cardiologists perhaps decrease some of them. So again, I think the jury is out on how we should use them, but so much excitement in terms of the clinical studies, I think, that need to be done or will be done to try and find out how we use these drugs. Now, I will say one thing. If you model the effects of these 4 different types of therapies, they do appear to be additive, both with regard to reducing cardiovascular endpoints, and very importantly, the modeling suggests that if you use a combination of an ACE-ARB and an SGLT2 inhibitor and a GLP-1 and a non-steroidal MRA, that you may be able to get a 68% reduction in your composite kidney endpoint. So this is huge. We've never had anything like this in the kidney world. And to me, and I'm an optimist, what that means is that perhaps the use of a combination of these drugs could in the future prevent people from needing dialysis, which would be absolutely huge. And so there is, in fact, a new paradigm for cardio-kidney metabolic health, because do remember, kidney disease does not occur in isolation. The patients who have kidney disease invariably have heart disease, they very often have diabetes, and they're often obese. So for this cardio-kidney metabolic patient, I think we could in the future be using this combination of 4 different drugs, ideally in the patients who have the most chance of heart problems and of progressing to chronic kidney disease, or rather progressing from chronic kidney disease into end-stage kidney disease. But what is even more important than surrounding these patients with these 4 different pillars of therapy is that we also have to think about things like equity and access to these therapies, quality of these therapies, and overall policy that will allow for the implementation of these agents. And I want to focus a little bit both on equity and access to care. So over 50 years ago, Martin Luther King said that of all the forms of inequality, injustice in healthcare is the most shocking and inhumane. And I would submit to all of you that we must, as nephrologists, as physicians, do better with these new therapies as compared to what we've done with dialysis. Because if you look at the middle panel, as a nephrologist, let's say in 2020, Amit and I could feel proud and happy that 3 million plus people are being dialyzed across the globe. But the real number is that in 2020, over 8 million people across the globe, and this number is almost certainly an underestimate, died because of a lack of access to dialytic therapies. And so I'm going to suggest and submit to all of you that the maximum impact of these pillars of therapy, these 4 new therapies, could actually be in parts of the world where there is limited access to dialysis because of cost. And I really believe that we have the opportunity to be able to do this. These drugs will soon be generic. About 3 weeks ago, I visited Dr. Reddy's laboratories, and both Dr. Reddy's laboratories and Sun Pharmaceuticals, both of which are big generic pharma companies in India, will be coming out with generic GLP-1s in 2026. Now, if you think about the cost of hemodialysis for a year in India, it's the equivalent of $6,000, which is basically the per capita income of the richest state in India, so Delhi or Goa. The per capita income for Bihar is $914. But the cost of a year's treatment with dapagliflozin in India is only $60. It's between 5 to 8 rupees a tablet as compared, and I laugh over here, to $300 a month. But prices both in the US and in India will actually come down even more. And so $60 a month or $60 a year or $30 a year, that's not a bad deal for the government if you can prevent a patient going on to dialysis. And of course, there's the economic cost and the quality of life issues and just the mortality that is associated with dialysis. So I think we have a huge opportunity, but I think we need to get it right. Now, what are the barriers to the equitable use of these new therapies across the globe? So the big one, of course, still remains cost, but the cost differential compared to dialysis, it's really a fraction of it. But there are other barriers, and they are shown on this slide. I'm not going to go through these in detail, but I just want to emphasize, from a patient perspective, they have to be vested in their care, right? They have to have self-care. There has to be patient empowerment. We'll speak about this a little bit more in a moment. From the clinician perspective, there's often guideline overload. So if you go to a primary care physician in the US, they have 10 different checkboxes that they get paid for. They're not going to use all of these drugs, although if there are primary care physicians in the group, I'd love to hear from you also, unless you actually get reimbursed, I would say, for your time. And then, of course, there are the socioeconomic issues associated with cost that we've spoken about. And that's just not an issue in emerging economies. It's an issue, hugely an issue in this country as well. And then there are health system issues such as care fragmentation. There are policy issues such as the lack of public awareness. I'll speak about this in a moment. And then, of course, there is the prioritization issue. We still live in a world where dialysis and transplant seems exciting and sexy as opposed to prevention of chronic kidney disease. Now, the one barrier that I really want to highlight is education and awareness. So if you think about patients with chronic kidney disease, the vast majority of patients in the United States and globally are unaware of the fact that they have chronic kidney disease. 80 to 93% are unaware, 7 to 20% are aware. And if you then look at the metrics that we are able to achieve in this 7 to 20% of patients that are aware of their CKD, it's really not very good. We don't do badly with RAS inhibitor use, but these drugs have been out since 1993. We do terribly with changes in lifestyle and diet. And for blood pressure in this group of CKD patients, only 40% are able to achieve a target blood pressure of under 130 by 80 millimeters of mercury. So how are the ways that we can intervene? So I think patient organizations have a huge role to play. Screening is important. So the United States, so the Public Health Task Force in the US advises for screening for CKD for patients at high risk, that's diabetes and hypertension. And of course, as kidney doctors, we would like to advocate, and we've pushed hard through the ASN for universal screening. Social media and apps become very important. Home testing, point of care testing becomes very important. Can we incentivize education? And really, the most important of all is that we need to have kidney champions. And I hope that by the end of this presentation, all of you will be kidney champions for preventing and, yes, trying to cure kidney disease. Now, I also want to emphasize that the excitement for new therapies in kidney disease is not just for chronic kidney disease and diabetic kidney disease, although clearly that's the 800-pound gorilla in the room. But think about lupus nephritis. We've been able to identify over the last few years, and I will say that the UNC Kidney Center and people like Dr. Vimal Derabel and Amy Mottle have done a lot of work, and my mentor Ron Falk have done a lot of work in this area. But we've been able to identify new mechanisms that have resulted to date in 4 new therapies: belimumab, voclosporin, anifrolumab, and also CAR T cells for lupus nephritis. Lots of new therapies that target different pathways waiting in the wings. And my sense is that soon we're going to have a precision-based approach to the therapy of lupus nephritis, which will in a way require even more clinical trials. But isn't this wonderful as compared to the let's give this patient steroids and cyclophosphamide, and if they can't tolerate cyclophosphamide, let's give them some mycophenolate mofetil, a totally new world. Very similar for membranous nephropathy. 20 years ago, 80% of patients with membranous nephropathy were termed to have idiopathic membranous nephropathy, which meant that we don't really know what's causing it. Now we know that 60% of this 80% is as a result of specific antibodies against the phospholipase A2 receptor and against thrombospondin. My apologies. But what about that 40% that we didn't know about even as early as just 4 or 5 years ago? Well, now we've got a spate of new antigens that we're recognizing that are the cause for different types of membranous nephropathy, as shown over here. And over here, you see an example of a glomerulus, which has been stained up with exostose, with antibodies to I keep pronouncing it wrong, exostin, which is one of the new antigens that cause membranous nephropathy. And of course, the excitement here is that if we identify the pathogenetic mechanisms for membranous nephropathy, we may be able to target them at an individual level. So nephrology now becomes, or glomerular nephritis becomes, a lot more like oncology, where you identify the problem and then you target it with a very precision medicine-based therapy. Similarly, for IgA nephropathy, we're learning of new mechanisms. So we've got new therapies, 3 new therapies: sparsentan, Tarpeo, and Fabhalta. Not going to go into the details, but again, lots of new therapies for IgA nephropathy coming out. And I want to tell you a story here about IgA nephropathy, which again, I think makes the case that yes, excuse me, that yes, mechanisms are important, but other things like creating the right sort of innovation substrate and sometimes luck is also important. So, excuse me, I'm just going to take some coffee. So the story of IgA nephropathy is that until about 5 years ago, there was very little innovation and no real treatment for IgA nephropathy, which really is the most common cause of glomerulonephritis. And the reason for this, in reality, was a business reason, which is that the complexity and cost of clinical trials in this area, when you use the FDA mandated endpoint of death, dialysis, and doubling of serum creatinine as an endpoint, just made these trials far too complex, because in order to get death or doubling of serum creatinine or dialysis, you really have to have a trial that goes for 5 to 8 years. Now, in order to address this, the Kidney Health Initiative, which, as Amit said, is a public-private partnership between the American Society of Nephrology and the FDA, a committee was brought together. They included members from the FDA, Eliza Thompson, shown over here. Patrick Nachman was the co-chair of the committee as well. And they were able to bring together all of the data in this area, do some modeling, and prove to everyone that if you looked at proteinuria at 9 months, so if you were able to demonstrate that a new drug for IgA nephropathy resulted in less than 0.5 gram of protein in the urine 9 months after treatment, that would almost always correlate with that other clinically relevant endpoint of death, dialysis, and a doubling of serum creatinine. And as a result of this, the IgA trial in 2025 is a 9-month trial. And after 9 months, if you can show a benefit, you can get your drug on the market, you can sell your drug. And as a result of this, over a dozen clinical trials are now ongoing. Clearly, all the clinical trials will continue so that they can demonstrate for sure that you also reach your longer endpoint of death, dialysis, and doubling of serum creatinine. But the world of IgA nephropathy has been changed, and with it, the world of kidney care and kidney disease. 10 years ago, when I used to go to the ASN, there was hardly any interest in kidney disease. If you went to the ASN, the American Society of Nephrology meeting last year, it was like the cardiology or oncology world. There were all of these banners, all of these plenary sessions, all of these New England Journal papers on new therapies coming out for kidney disease. So with that, I'm excited that we may actually in the future be able to cure chronic kidney disease. But I'm also a realist, right? I'm not sure that we'll be able to cure it completely. I hope we can. But what I also want to tell you about is that in addition to preventing the progression of chronic kidney disease, we can also change how we dialyze people. And so in the next 10 minutes, I'm going to speak about innovations in hemodialysis. I want to start off by saying that at this point in time, we provide very poor value for hemodialysis. And the reason that we provide such poor value is that we spend a lot of money, but we get very poor outcomes. So we spend this $34 or $40 billion on dialysis, and what we get is a 41% 5-year survival, which is actually worse than most forms of cancer, other than some forms of hepatobiliary, lung, and brain cancer. And this is without any consideration of quality of life. Now, one of the reasons for this, in my mind, is that we haven't had very much change in dialysis technology. So the panel on the left shows you a patient undergoing dialysis at the Royal Free Hospital in 1965. The panel on the right shows you a patient in 2015. Yes, there is some miniaturization. Yes, there are more bells and whistles, but the basic construct of dialysis has not changed in 50 years. Now, I want you to keep this picture in your mind as I go to my next slide, which shows to you the changes that have happened in another technology-rich area of life, which is computing and cell phones. And I would guarantee to you that any of these little devices on the right has as much or more computing power than this big IBM machine on the left. Now, when you think about dialysis, history is important. history is always important. So I just want to share with you a little bit of history of dialysis. So the first dialysis took place in 1944 in a little village called Kampen in the Netherlands. And the pioneer of dialysis was this man you can see on the left, Wilhelm Kolff. And he was an incredible man. I want to make 3 points from this slide. Number one, if you look at this slide, which shows you the graph of the patient who underwent the first dialysis, I want to point out to you that this says patient number 17. In fact, Kolff tried his dialysis machine, which was this rotating drum around which he had wrapped some sausage skin, and the blood flowed from the patient into this sausage skin, and the drum was rotated in a bath of dialysate. But this was patient number 17. 16 earlier patients had died. So he was persistent. The second interesting thing in this slide, and I don't know whether this is urban myth or not, is that apparently the patient, and this was the first patient in dialysis, when she woke up after this dialysis, she said, I'm going to divorce my husband. But the third is really the most important thing in this slide, and it speaks to the sort of person, the sort of man that Kolff was. So after the war, Kolff sent his dialyzers to 4 countries. No intellectual property, no cost. He sent it to Canada, to the UK, to the US, and to Poland. And all of these 4 countries actually were countries whose soldiers liberated the Netherlands from Nazi Germany at the end of the Second World War. So truly a great man. I never really met him. I did see him at a meeting once when I was very, very young and just starting off in nephrology. Now, the second thing I want to say, and this is again a bit of history, when dialysis started off, it was really totally impossible to dialyze everybody who had kidney failure. And at this point in time, a documentary was made about the early days of dialysis. And I really want to play that to you because even though I have criticized dialysis in some ways, I also want to go on record as a nephrologist by saying that we're extremely lucky as nephrologists, and I think nephrology, and I think this is a success of nephrology, that we still have the only form of organ replacement therapy that actually works over a period of 10, 20, 30, 40 years. So my son, who's a cardiologist in training, gets excited about LVADs, but you can't live on LVADs forever. But listen to this CBS documentary. It tells you how lucky all of us are at the present time.
Nothing can work. The heart can't work, the brain can't work, the lungs can't work. Nothing can work effectively unless the kidneys regulate the intricate chemistry of the internal meeting of the body.
Prior to 1960, it was not even considered possible to treat patients who would not recover their kidney function. In other words, patients with chronic kidney disease were all doomed to death.
When first invited to serve on the committee, I was very uncomfortable, feeling that I was taking the place of God.
Financially, we couldn't afford it. I suppose that I would just die, but I would trust God and pray that I wouldn't die.
The doctor said that I had approximately 2 months to live.
My strongest feeling is that this kind of a committee should not have to exist.
This is going to cost and run into an awful lot of money, maybe billions of dollars. Where are we going to get the money? That's what some of the taxpayers ask us.
It's bad business in more ways than one to let people die. It's good business in plain dollars and cents to keep productive individuals alive today.
Step number 4, the last step in the screening process. The applicant must be approved by a jury of his peers. These are volunteers, anonymous.
Nothing can work.
Oops, sorry, my mistake.
The brain can't work, the lungs
Machine, and there are more applicants than places. Somebody has got to be left out, and somebody has got to decide who shall live and who shall die.
So that's what it was in the 1960s. Now, in 1972, a law was passed that made everybody with end-stage kidney disease a Medicare patient, and so Medicare now pays for all end-stage kidney disease care in the US. So the death panels are long gone. Hemodialysis is routine. 550,000 patients on hemodialysis in the US. I spoke about the fact that dialysis remains, and we should be proud of this as nephrologists, the only reliable and long-term form of organ replacement therapy. But I will also say, and we spoke about this earlier, that for most of the world, the ability to pay still remains the prime predictor of who will receive end-stage kidney disease therapy and who will not. Now, even if you think of the US, we're successful in dialysis, but we've forgotten something. So right at the start of the dialysis period, Willem Kolff said, if the treatment of chronic uremia cannot fully rehabilitate people, then that treatment is inadequate. And I would submit to all of you that dialysis at the present time keeps you alive, but dialysis does not allow you to live. Our patients are tired. Our patients are in hospital all the time. Our patients are the sickest of the sick when they're in hospital. So how do you change this? Well, one of the ways that we felt that we could change it was to create a technology roadmap for innovative approaches to renal replacement therapy. And we did this through the Kidney Health Initiative, which, as I mentioned earlier, is a public-private partnership between the American Society of Nephrology and the FDA. And I was truly privileged, as Amit said, to be the founding co-chair for the Kidney Health Initiative. It actually changed my perception, made me a much more holistic person. Now, what we did in the roadmap is that we created a technical plan in great detail that would allow us to go from better dialysis to a portable wearable dialysis to a biohybrid or implantable kidney, and then finally into the creation of a regenerated kidney. But the most important thing about this roadmap is that even though we didn't know, we still don't know at the present time what that final type of dialysis will be. My dream is that it'll be like a cell phone that you clamp onto your arm and hey, you can dialyze. But whatever it's going to be in the future, we were all very clear that it has to improve the patient's quality of life. In other words, whatever the dialysis of the future will be, it has to give patients an improved ability to work and travel. It has to increase their mobility and physical activity. It has to liberalize their diet and fluid regulation. It has to reduce their medication burden. It has to reduce hospitalizations and interventions. And very, very importantly, it has to reduce the financial impact of the patient, because regardless of which part of the world you live in, all chronic diseases drive people into poverty, and there isn't a chronic disease, though, that does it as well, unfortunately, as chronic kidney disease. The other thing that's very important in the roadmap is that it pays a lot of emphasis to device regulation and reimbursement. And again, the message here is that you can have the best idea, the best biology, the best drug or device, but if you don't have a regulatory and reimbursement pathway for these new drugs and devices, they're never going to get to the patients who are desperately waiting for them. Now, a lot of the roadmap is clearly a technical roadmap, but for our patients, this is a roadmap to freedom, which will take the patient on dialysis from being stuck in a chair in-center dialysis to being able to travel with portable dialysis, and finally being completely normal with an implantable kidney in the future. And I would say that when we think about freedom for our patients, we are limited only by our imagination. So this is an example or a picture of a dialysis patient, Bill Peckham, who unfortunately has died. Remember, patients on dialysis, 5-year survival, 41%. But this is a picture of Bill rafting down the Grand Canyon. Only 0.00001% of our dialysis patients can do this. But why can't more of our patients be able to do this in the future? Now, you may ask me, and you will be right at this point, if you say, Prabir, is this too much too quickly? Do we actually have the science for implantable and regenerated kidneys? And the cartoon here says, I'm a fiction writer in the grant proposal genre. But I, again, will suggest to all of you that we do have the technology. We can now photo-oxidize urea into nitrogen and carbon dioxide. And on the right panel, you see an example of a kidney that can actually do that from Kulyana Technologies, which means that you could carry it in a backpack potentially. Shuvor Roy and Bill Fissell are working on the kidney project, where you have a little thing about the size of your fist. It's shown over here, connected to the artery and vein, connected into the bladder. You have silicon nanomembranes layered in some cases with tubular epithelial cells to replicate filtration and reabsorption that the kidney does. We're very interested at UNC in creating the next generation graphene oxide membranes for hemodialysis. And these are membranes that have 2,000 times the surface area of your normal polysulfone membrane. So a little membrane about the size of the tip of my finger has a surface area the size of a football field. So again, huge opportunities here. And then lots of work on organoids. And there's actually data which shows that if you put flow, if you run fluids over organoids, that they actually come together, which could allow for kidney regeneration or creation. And then, of course, there's xenotransplants, right? When I grew up, when I was a young nephrologist, the dictum was that if you put a pig kidney into a human, you have preformed anti-pig antibodies against the alpha-gal component on endothelial cells, and you're going to get a black kidney. Well, if you look at the pictures here, you can take a kidney and do gene editing through CRISPR-Cas technologies. You can get rid of the alpha-gal protein in the pig kidneys. You can get rid of endogenous porcine retroviruses, and you can have a kidney that you can perfuse for days on end without any hyperacute rejection. And the picture on the right demonstrates or shows you the first person over here at the Mass General who received a successful xenotransplant. The kidney lasted beautifully for 2 months. The patient did die, but it was as a result of a cardiac event. Again, remember what I spoke about, chronic kidney disease, huge incidence of coronary events. So I think xenotransplant could change things. And finally, before I get to my messages for the future, policy. Policy is really important. We now have the Advancing American Kidney Health Initiative, which really champions a global payment system. Now, there are nuances, but in general, you can think about this as getting a lump sum of money or a sum of money with incentives for certain metrics, and then you can share in either the profit or the loss. Now, my way of thinking about these global payment plans is that they may actually be able to incentivize novel therapies, because let's suppose that in a fee-for-service, eat-what-you-kill system, you have a continuous wearable device that reduces cardiovascular morbidity and hospital admissions. Well, that may not be that attractive to pay for in a fee-for-service model because it's extra cost up front. But in a global payment system, if you can reduce hospital admissions, have better quality of life, then that becomes extremely attractive, because the savings from hospital admissions would ultimately come back to healthcare systems as a profit. So finally, some messages for the future. I have, I think, 3 messages. So the first one comes back to patients. It's really important to involve patients in innovation. It's really important to get the patient perspective for new therapies and new innovations, because the things that are important to patients are very often not the things that are important to physicians. So in dialysis, for example, patients want flexibility. They want to be able to travel. But as nephrologists, I'm basically focused on survival and blood pressure. This is a video that was made by the patient on the right, Celeste Lee, and more than anything else, in my mind, it brings out the benefits and the importance and really the excitement about doing the right thing if we can involve patients in innovation. So have a listen.
Hello, I'm I'm Cece, a fellow kidney disease patient. For 33 years, I've done dialysis, both chemo and PD. I had a transplant for 10 years, and as you can imagine, too many pills, shots, and accesses to mention. As kidney patients, you and I both know that a few things in life are not optional. Strength, courage, persistence, and determination. No matter what life throws at us, we try to stay balanced, maintain our routine, and remain positive. But let's face it, we are often in a holding pattern. Kidney disease treatments have not changed much over the years. The options for patients like us have largely remained the same for many years. You want to help change that? We need you. Each day we're asked to share our lives with our treatment. But now let's share our voice, ideas, opinions from patients like us. They matter. Few people are realizing our voices matter too. Here's what I found out. The Food and Drug Administration, often known as the FDA, is looking for patients living with kidney disease, like you and me, to provide input on how potential treatments of the future could look. Picture a big table. Around it are dialysis caregivers, researchers, doctors, nurses, and companies providing new products and treatments. They want us and our families to sit beside them and have a seat at this table. We'll work together to bring potential new treatment options, safe and effective ones, and ones that patients like you and me want and need. Imagine the future of your treatment. What does it look like? How does it improve your day-to-day life? This future doesn't have to remain just a dream. Join me and other patients to contribute our thoughts and make our ideas a possible reality. This is my invitation to you. Lend your voice and work with the people who can help make it happen, with one shared goal: living better with kidney disease.
So again, what I want to emphasize is that this video was made by Celeste Lee. She died again about 5 years ago, and she died because her bones had become so brittle after 25 years of dialysis that her sternum was literally compressing down on her heart, and she stopped dialysis. And again, I think, her story, I think, is a charge for all of us involved in kidney disease to target the issues that are important to patients. The other thing that I personally have learned from my interactions with patients, particularly through the Kidney Health Initiative, is that there is an urgency to try and develop new therapies, both for preventing chronic kidney disease from going into dialysis and for developing better forms of dialysis. Because, if you're thinking about something that's going to happen in 15 years, and at the same time, we're telling patients that your 5-year survival is 41%, then something isn't quite right? We need to have this urgency to develop new therapies. Let me see, why isn't it going forward? Okay, so my second message is that if you really want to create change in kidney disease, and this is true for all sorts of diseases, is that you really need to develop a patient-centered innovation substrate or ecosystem for discovery innovation, new drugs, and also for process of care innovation, implementation. And this needs to go all the way from biology to technology to patient care. From initial ideation and investment to the identification of druggable targets and deviceable targets, to creating the surrogate endpoints that I told you about, and then into regulation and reimbursement. And then once you have this innovation substrate, and I think we've begun to have it in the kidney world, you need to surround it with equal measures of equity and access to care. So some of the other things that Martin Luther King spoke about over 50 years ago. Now, I would say that in the kidney world, we're moving ahead. We're at this point where we probably have 10 new ideas or seeds coming out, and we have an innovation substrate that will allow one of these seeds or ideas to flower into a sapling, i.e. a new product. But this is where we need to be in the future. We need a lot more ideas. We need young people to come into our field because young people have the best ideas. We need to have 50 seeds or ideas come out, and we need to have an innovation substrate, things like the Kidney Health Initiative, better clinical trial endpoints, roadmaps, for example, which will allow these 50 seeds to flower into not 1 or 2, but 20 saplings or different products. Again, a bit idealistic, but I think we are going in the right direction. And then my last message is really an African proverb, which says, if you want to go fast, go alone. If you want to go far, go together. And I would say that we want to go far in kidney care. We want to be disruptive in our innovation. We want to have good outcomes at affordable cost, right? Again, we spoke about global equity. We want to have, I'm repeating myself, equitable access to kidney care. And if we want to be able to achieve this, we have to go together. Physicians, scientists, engineers, industry partners, federal agencies, and very importantly, patients. And when I talk about patients, I once again think about urgency. So maybe we want to go far, we want to go together, but perhaps we also have to try and go fast. We have to have some urgency. And then my last message is that it's always about people. Change and innovation comes about as a result of people. And I just want to end with this quote from Margaret Mead, which says, "Never doubt that a small group of thoughtful and committed citizens can change the world. Indeed, it's the only thing that ever has." And on that note about people, I just want to say that I am incredibly grateful to all the many, many people that I've worked with, people in the American Society of Nephrology and the Kidney Health Initiative, a lot of people from the FDA, and I think their input has contributed to this presentation. I'm lucky to have a wonderful team within my lab. We collaborate with a whole host of different types of people, both at UNC and outside of UNC. And just look at the sorts of people that I'm so lucky to work with in biomedical engineering, radiology, mathematics, chemistry, biology, chemical engineering, mechanical engineering. This is what, again, it's all about team science and being really multidisciplinary, and that makes the world so much more exciting. I'm very grateful, of course, to my sources of funding. And finally, from the University of North Carolina Kidney Center, thanks to all of you for your attention. Amit, I've gone a little bit over, but I think we started a bit late. I'm happy to take questions, and I will stop the share.
Thank you. Thank you, Prabir. That was really an eye-opening talk in terms of very thought-provoking. So I'll start off with some questions that have been posted in the chat panel. So Dr. Bikram Paul, he said DAPA in US is over $900 per year according to Medicare PDP. Many new drugs have major side effects leading to many other medical problems. How do we solve this?
Yeah. So I'm just looking at the, okay, yes, I have it, Dr. Paul. Yes, and I see you, Dr. Paul. Yes, so I think so I think the answer is two parts. So I think that as these drugs become generic, the cost will come down. I personally am in favor of the Inflation Reduction Act, and dapagliflozin is actually one of the drugs on that list. But the second way is that I think, and that goes towards the precision medicine approach that I've spoken about. I think we need to identify those patients that will benefit the most from different drugs. Now, I will say that there could be some diseases like diabetic kidney disease where maybe we do need lower doses of, let's say, all 4 drugs. But even within diabetic kidney disease, there will be some patients who maybe will do best with a GLP-1 agonist. And I'm talking about progression of kidney disease and reducing cardiovascular events. And others may need different sorts of combinations. And the studies to identify this have actually started to be done. So there's a study called Confidence, which is taking patients with diabetic kidney disease, giving, and on a background of ACEs and ARBs, is giving one group of patients an SGLT2 inhibitor, another group a non-steroidal MRA, and a third group the combination. So I think your point is really well taken. I think we need to be more precise because if we can identify the people who will have the best effect with the minimum side effects, then we're golden.
Yeah. Okay. And then the next comment was, any comments on peritoneal dialysis? Because most of the data we were talking about was hemodialysis.
Yeah. So I am remiss in the interest of time. I couldn't cover everything, but I would say that I think that there can be innovation, and there is actually innovation in peritoneal dialysis, going down the similar pathway of becoming more portable, being miniaturized. So there is actually something called the automated wearable artificial kidney, which is sort of the size of a briefcase or a laptop case, and it actually recirculates the PD fluid, which means that you could travel out for a week and you could carry that laptop thing with you, and just with 2 liters of fluid, it keeps purifying the fluid. So I think, yes, there are advances in peritoneal dialysis as well. And again, to the question that was asked earlier by Dr. Paul, even in the setting of dialysis, I think it's good to have, or even in the setting of end-stage kidney disease, I think it's good to have many options, right? Portable PD, implantable hemodialysis, regenerated kidneys, and xenografts. So again, it's a question of which is the patient that's best suited for different types of therapies.
Great. Dr. Nathan had a comment about living kidney donor transplant being the best treatment option, and how can we convince someone to give a gift of life. Again, that's a universal challenge or the need.
So, but I will comment on that. And I think this is not a medical issue, right? This is a societal issue. So countries like Spain have active living donor programs. They have active deceased donor programs. So I think this is a mix of society coming together and realizing how important this gift of life is. It's an issue of people who are well known, whether they're sportsmen or film stars or politicians or tech titans, coming and making the case for living donation. But most importantly, and I'll come back to this champion issue, it depends on all of us, right? Society is all of us. All of us have to be champions for living donation. All of us have to sign our driver's license for giving a kidney. All of us have to tell our family members that if we die, I want to give a kidney. And I understand we were talking about living donation. I'm sort of talking about everything, but it's that sort of societal push that, giving a kidney, whether from a living person or after you've died, is an important thing to do.
Okay. Next question is from Dr. Neravetla. Given that hypertension and type 2 diabetes, both of which are largely preventable and top two causes of CKD, perhaps the kidney foundations and nephrology too should address public policy, and neither India nor US have any meaningful strategies to reduce salt in processed food opposed to 100 other countries. And secondly, the Black America pays a huge price for malignant hypertension. 1/3 of all Americans on dialysis are Black Americans, many younger than Caucasian.
Yeah. So I agree with you completely. Again, I could not cover everything in my presentation, so I think I was remiss in not covering this. But yes, diet, reducing salt, reducing, not supersizing everything. These are really important things, but they will only happen if, just as you say, I'm blanking, Surinder, just as you say, these have to be policy changes, right? It's critically important. Again, Robert F. Kennedy, whose nomination goes through, I think, in the next, or doesn't go through in the next 24 hours, has actually been, despite all the vaccine issues, has been an advocate for exactly the sorts of things that you speak about, Surinder. And a lot of us, have been sort of wondering, what's going to happen if he actually takes on the big food lobby? I don't know. So I think, again, this is a societal issue. We have to vote in. I don't want to get political, but this is something that it is in all of our hands, and it's very much policy. I will say that the FDA has actually been trying to move in this direction. Rob Califf, who has been a huge supporter of many of the things that you say, Surinder, has actually tried hard to reduce, to actually have more information on the salt content of foods. New York, for example, under Tom Frieden as a health commissioner, actually took some concrete steps in the right direction. So again, I think many people are aware of this. I'm sort of reminded, unfortunately, and of a cartoon that was on my WhatsApp group, actually from my medical school WhatsApp group, which had a huge line. It had a lot of people, a huge crowd, and one arrow said, "New drugs for reducing obesity and improving cardiovascular health." And there were 10,000 people in that row. And the other line, or the other sign, was healthy diet. And there was one person on that side. So again, I think all of us have to push for that as well.
Yeah. And then the next question was relationship of obesity without diabetes and CKD. So obesity as
yeah, so again, if you don't have diabetes and you don't have CKD and you're obese, you have a huge increase, obviously, in cardiovascular risk. Regardless, you have a huge risk of becoming diabetic, and then you have a huge risk once you have diabetes of having chronic kidney disease. So I would say, again, it's diet, it's exercise, it's use of the new weight loss therapies. And, will large portions of our population be on Ozempic or similar drugs in the future, similar to statins or antidepressants? I don't know the answer, but I think the answer could well be yes. Will we as a society be healthier as a result, with less hospitalizations and better quality of life? Again, I think time will tell, but the answer could be yes. We failed miserably all over the world in attempting to, again, I think policy is important, but we haven't been very successful in tackling the epidemics of obesity and diabetes and hypertension across the globe.
Okay. And in interest of time, we'll just quickly address two other points. Why not get or partner with the media and spread awareness? People know about heart problems, diabetes, and cancer.
Yes. So again, whoever asked that question, I think that is very, very important. And the fact that there are these new therapies, in a way, is good, because now at least the message for early diagnosis and early treatment makes sense, because there are ways that we can treat you. So I think that that's a big plus. There's obviously industry interest, which can be a double-edged sword, but could also be positive. We're getting ads on TV now saying it's not the ideal world, but at least kidney disease is out on TV saying, ask your doctor about dapagliflozin. And then most importantly, we do need to be like oncology, right? I fly Delta a lot. They paint their planes pink, right, when you have Breast Cancer Awareness Month. And I think a lot of different organizations in the kidney space are trying to do that. I do believe that and again, I speak as a nephrologist and as a kidney person, I think that the new drugs and the appreciation of cardio-kidney metabolic disease will give nephrology a chance to break out of its relatively small bubble and play in this much larger bubble. And I think that that's going to help also with more education and more awareness. But again, I come back to, it does begin with all of us, and we're a physician group. And, there have been study after study done, which says that both patients and physicians are often unaware of the early stages of chronic kidney disease. And again, I did speak about all the different reasons for that, right? So many guidelines, not enough time. But again, I've digressed. I've digressed a little bit. But yes, education and awareness is important. But the fact that we have new drugs, I think, makes it easier to do it.
Okay. And very lastly, very briefly, I think you've touched upon that as well, that just like oncology, where they can sometimes cause much harm with all good intentions, we are talking about kidney disease interventions, but do we have concise literature source in terms of prevention of CKD in general? And yeah.
So say that again, Amit. I'm trying to look for the question. Which one is it? Who is?
Radhika Rajshekhar. And so oncologists can cause so much harm with all good intentions, but we do have guidelines in limited scenario how to prevent kidney injury and monitoring renal function, preventive measures. But do we have concise literature source?
Yes. Okay. Yeah.
Preventing CKD, like prevention of CKD.
But it's related to onconephrology, correct?
No, just ignore that part. Yeah, no, that's just a comment. Yeah.
Oh, that's a comment. Can so much. We do have guidelines how to prevent. Yeah, so I'm not sure. So the question, as I read it, suggests that, so we do have the American Society of Onconephrology, and if you go to their website, there will be information about guidelines for onconephrology. If you're talking about guidelines overall, I would say that we really have, some of the studies that I described. So if the question is, do we have guidelines that tell us about the side effects of the new therapies? I would say that yes, with the clinical trials that have been done for SGLT2 inhibitors and GLP-1s and non-steroidal MRAs, we do have good guidelines about how to use them. But I will say, of course, that clinical trials are done, they could be done in 20,000 patients. If you use them in 200 million patients, you may find side effects. And that's why being aware and doing post-marketing studies is very important. I apologize if I didn't answer that.
No. Thank you, Prabir. No, this was great. And with this, we'll wrap it up. And there are a bunch of congratulatory messages. We'll try to save that chat for you. And definitely, I'll let Dr. Kattula take back the forum. Yeah.
Thank you, Dr. Prabir Roy-Chaudhury, for this excellent talk, world-class presentation. So we thoroughly enjoyed it. And thanks all the audience for attending today's webinar. And I have a comment to make, Dr. Roy-Chaudhury. We did what is called Adoptive Village program through API. I was the chair of the program. So we screened asymptomatic patients in 75 villages up to 10,000. And as you rightly said, it's a global problem, the CKD. And we found 45% of them had unknown, chronic kidney disease, stage 1 to 4. So it is definitely a huge problem globally, and definitely prevention really makes sense because of lack of infrastructure like in countries like India. So I think we should emphasize on education, prevention and policy and other things. So through API, we are trying to make a preventive task force to prevent all these non-communicable diseases, including chronic kidney disease. So, and I really thank for your time today for enlightening us with this important topic. And we have a little virtual plaque presentation.
Okay. Oh my goodness. Thank you.
All right. So it says American Association of Physicians of Indian Origin recognizes Prabir Roy-Chaudhury, MD, PhD, FASN, for his outstanding contributions in the field of nephrology, and welcomes him as a member of API Distinguished Speakers Club. Satish Kattula, API President, and Amit Govil, Chair of API CME Committee, February 12, 2025. Thank you so much, Dr. Roy-Chaudhury, for your time again.
No, thanks to both you, Amit, and to you, Satish, and most importantly, as Satish said, thank you to all of the attendees. I know it's late, and it gives me immense pleasure and satisfaction to be speaking to an audience of my peers who are from India or of Indian origin. So thank you so much for this opportunity.
Thank you, Prabir. Thank you so much.
Thank you, Amit.
Thank you, Satish.
Good night, everybody.
Good night. Good night, everyone. Thank you.
Take care.